Hello students. So today I will discuss about electric forces between two charges. Okay, this is the second part of this chapter, that is electric charges and fields. The second part. In the first part I have discussed about the electric charges, the property of electric charges, and the ways how to charge a body. Okay. Now here I will discuss about, that is, the force between, the electrical force between two charges. Okay, or multiple charges. The first that we discuss about, that is Coulomb force or Coulomb's law. Now according to Coulomb, the force between any two charges in vacuum, suppose these are two charges, say Q1 and Q2, and they are placed in vacuum, separated by distance, suppose R. Okay. Now according to Coulomb, the force, the magnitude of force between any two charges in vacuum is directly proportional to product of the two charges, okay, Q1, Q2, and inversely proportional to square of the distance. Or you can write F is equal to a constant K, Q1, Q2 by R square. Okay, so this is Coulomb's law, or you can say Coulomb force between any two charges. It depends on what? Product of the two charges, and inversely what? The square of the distance. Now here the value of K is, where K is actually is given by 1 by 4 pi epsilon naught. This is a constant, okay, I will discuss. Its value is 9 into 10 to the power 9, okay, Newton meter square per Coulomb. Now what is this? This is called epsilon, okay. This is not 0, epsilon 0, you can say epsilon 0 or epsilon naught. So this is called electrical permittivity. This is called absolute electrical permittivity. Okay, permittivity of vacuum. Permittivity of vacuum. Its value is equal to 8.854 10 to the power minus 12, okay, Coulomb per Newton meter square. So this is the value of what? This is epsilon 0. Okay, now absolute electrical permittivity of vacuum. Actually, the electric force, the Coulomb force between two charges depends on medium. If we place two charges in air, in water, or in any presence of any other liquids, the force between them changes, and that's why we are using this permittivity, because depending on medium the value of it changes. For vacuum only, its value is this, okay. If it is any other medium, so this value will change. If this value will change, means force between two charges will change. So we can say that Coulomb force depends on what? Medium between the two charges. So this is called Coulomb's law. That is, force between two charges is directly proportional to what? Product of the two charges, and inversely proportional to what? Square of the distance. So this is the Coulomb's law. So in terms of epsilon 0, how can you write this? This you can write F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay. So this is the Coulomb's force between any two charges placed in vacuum. This 0 we use for vacuum. Okay. Okay, now let me discuss about this epsilon 0. Okay. So this is Coulomb's law. I think you understand about Coulomb's law. Okay. Now let me discuss about relative permittivity or dielectric constant. dielectric constant. Okay. Relative permittivity represented by epsilon r. R for relative, okay. And dielectric constant represented by what? K is capital K. K for dielectric constant. Okay, now you know the Coulomb force. The Coulomb force between two charges. Between two charges in vacuum. This I have already given you. That is F is equal to 1 by 4 pi epsilon naught Q, say Q naught by or Q1 Q2 by R square. So this is the force between two charges in vacuum. Okay, this is equation number 1. So here this is what? This is epsilon 0. This is what? Absolute permittivity of what? Vacuum. Now the Coulomb force between any two charges or same two charges between the same two charges in medium. Okay, now you place the two charges medium, then it will be what? F will be, say Fm, F for medium. Okay, 1 by 4 pi epsilon naught. Now in place of epsilon naught we place what? Epsilon. Okay, we place epsilon. So here you see epsilon naught, not for vacuum. And since it is medium now, we replace by simply epsilon. So Q1, Q2 by R square. Okay. Now here you see this is the absolute permittivity of what? Medium. So now you can see the change. If the two charges placed in vacuum, you use epsilon 0. If two charges placed in medium, you epsilon. Okay, the values are different. So its value is fixed. I have already given you. But its value is what? It depends on what? What type of medium it is. It is water, air, any other gas, any other liquids. Depending on the medium, its value will change. It's vary. Okay, but for vacuum it is fixed. Now if we divide equation 1 by 2, what do you get? F by F medium. So it will be, you see this part is same. So this pi cancel out. 4 pi cancel out. So what remains? It will be epsilon by epsilon naught. So this is called epsilon R or K. So both are same meaning. Okay. So this is our what? Relative permittivity. This is what? Relative permittivity. Okay. Permittivity. And this is what? This is your dielectric constant. Dielectric constant. Now from here you can define now. What is relative permittivity? How can you define? Relative permittivity means what? It is a ratio of, okay, it is a ratio of absolute permittivity of medium to the absolute permittivity of vacuum. So this is called relative permittivity. Same definition for dielectric constant also. Ratio of absolute permittivity of medium to the absolute permittivity of vacuum. Now here you can define these two in terms of force also. Now here you see what is F here. F is the force between two charges placed in vacuum. And what is Fm? Force between the same two charges placed in what? Medium. So you can define the relative permittivity as the ratio of the Coulomb force between any two charges placed in vacuum to the Coulomb force between same two charges placed in medium. Okay, so force between two charges in vacuum to the force between two charges in medium. That ratio of force is also called what? Relative permittivity or dielectric constant. Clear? So you can define these two in terms of permittivity also, in terms of force also. Okay, so this is about permittivity. Okay, so here its value is fixed. If you remember this, and this value depends on medium, it will be given. Suppose if some questions come from this part, the value of permittivity of that particular medium will be given in your theory. Okay. Now you know Coulomb force, since it is a force, and you know force is a vector quantity, so obviously Coulomb force also has directions. So we have to understand about the direction of what? Coulomb force. And for that, let me write Coulomb's law in vectors form. Okay. Coulomb's law in vector form. Okay. Coulomb's law in vector form. Now here you see, suppose there are two charges, Q1 and Q2. Okay, point charges separated by distance r. Now as we know, like charges repel, unlike charges attract. So this point you have to remember. In order to find the direction of force, only you have to remember what? You have to remember what? You know, like charges repel and unlike charges attract. Okay, only you have to remember this. And just this is very important for this chapter. If you don't understand the direction of force, you can't solve numericals from here. Okay, so like charges repel, unlike charges attract. So here you see, repel means what? Move away. Attract means what? Come closer. So here by convention we are using two positive charges. Say both are positive. Now what happened? This Q1 charge repel Q2. Similarly, Q2 charge repel Q1. So since Q1 repel Q2, so Q2 will move along this direction. Okay. So this force we take F21. Why F21? F21 means force on charge 2 due to charge 1. Similarly, so here F21 is what? Here F21 is force on charge Q2 due to Q1. Similarly, the Q2 charge repel Q1. So Q1 will move along this. Okay, to move along this. So this is suppose F12. So because it repels it, repel means what? It will move away from the charge. So here F12 means force on charge Q1 due to Q2. Now to represent the directions, we use unit vectors. You know unit vector? The vector's magnitude is 1. It is only directions. So what is the direction of F21? You see, it is along the direction of the line joining from Q1 to Q2. So for this, we use the unit vector R12. Okay. Now what is R12 here? R12 is unit vector extending from you can say unit vector along the line joining what? Q1 and Q2, along the line joining Q1 to Q2. Then to represent this F12, it is along the line what? Q2 to Q1. So use another unit vector, say R21. What is R21 here? R21 means unit vector along the line joining Q2 to Q1. Okay. So now, if we write the formula for F12, what will be F12? We write in vector form. Coulomb force, you know, 1 by 4 pi epsilon Q1 Q2 by R square. Now here, since I have written it in vector form, you have to assign direction. So F12, you see the direction of F12. This F12 along this. So what do we use? We use unit vector R21. So here it is R21. Okay. say equation number 1. And what will be F21? F21 means this force. So it is also same, 1 by 4 pi epsilon Q1 Q2 by R square. Here it will be R12, because you see direction of F12, direction of F21, this F21, it is along what? Q1 to Q2. So R12. Now here you see this part is same, you see this part and this part is same, you see same, only this is difference. Here R21 and R12. So here these are unit vector, so they have same magnitude 1, only direction is different. One is from Q1 to Q2, another is from Q2 to Q1. So here you can say, since R12, R21 is equal to what? Minus of R12. Why it is minus? Because same magnitude but opposite directions. So therefore you can say that F12 is equal to minus of F21. So what we observe? What do we observe from Coulomb's law in vector form? We observe that, you see, the two forces are equal and opposite. That means the force on this charge due to this charge is equal and opposite force on this due to this. That means they experience equal and opposite forces. So which is nothing but action and reaction. Okay, every action is equal and opposite of what? Reaction. So whatever the force exert by this charge on this charge is exactly equal and opposite force exerted by this on this. So you can say that from here it verifies what? Newton's what? Third law. Okay, Newton's third law. That is, for every action there is equal and opposite reactions. So here in fact it is very simple, only direction part you have to remember, and for that I already given you like charges repel, unlike charges attract. So later on I will do some numericals based on the direction of forces, then it will be you can easily understand from that. Okay, now here you see this Q1 repels Q2, so the force on Q2 is what? F21 along this, repels. Similarly force on Q1, it repels this, so it comes along this, so F12. Okay, so this you have to remember. So this part is not important for your CBSE board exam. Okay, so board exam it will not ask to write Coulomb's law in vector form. Only just you have to understand the direction of force. Okay, just to solve numericals, nothing else. So just you try to understand this. You need not to practice it. You need not to memorize it. Okay, it's not important. In board exam, it will not be asked. Okay, now let me discuss about force on multiple charges. Force on multiple charges. Multiple charge, which is principle of superposition. This is important, okay? Principle of superposition. The force on multiple charges means what? Force on more than two charges. Okay, here you can consider more than two charges. Suppose here we have a charge, say Q0. Now here a charge, suppose Q1 at a distance say R, say 1, 2. Okay, so this is another charge Q2 here, distance R, sorry, it is 1, 0, R2, 0. Here's another charge Q3, this is distance R, 3, 0. Unlike suppose here a charge Qn, that is R and 0. Now this charge repel this charge repel this charge repel this charge repel this. So if we want to find the total charge, total force on this charge, it will be what? Simply vector sum of all the forces due to all other charges. That means this charge repel this. What is the direction of that? So this you just join the line, okay, this direction. So this is F01. 0 means what? Force on the charge 0 due to charge 1. This Q2 repel this. So this is the direction of force, you see, line joining. This is F02. That means force on the charge Q0 due to charge Q2. Then this Q3, it's also repel this. What is the direction? Along this. So this is F03. That means force on the charge Q0 due to charge Q3. This charge also repel this. This along this. That is F0n. Force on the charge due to charge n. So now, if we say that what is the total force on this charge? The total force on this charge, the total force on charge Q0. What is that? F will be what? It is vector sum of all the forces, F01 plus F02 plus F03 up to F0n. Okay. So this is called the superposition principle. This is simple. In fact, in doing numericals, you have to find, by finding the direction of these forces, you have to find the resultant force by using, vector law, triangle law, or parallelogram law, like that. That we will see. Now, what is principal superposition? The force on a charge at rest, okay, due to all other charges at rest, is equal to vector sum of all the individual forces on the charge taken one at a time. That means you have to find the force F01, F02, F03, F0n. Then you have to add them vectorically. That means you have to, by finding the directions, then you have to find the resultant. Okay. I think in class 11 you understand to find the resultant. Okay, of any two vectors, any three vectors, like that. So that resultant part, okay, resultant vector you have to find out from here. We'll see in numericals. So basically, what is the superposition principle? The total force on a charge at rest is equal to what? Vector sum of all the forces due to all other charges at rest. So this is called what? Principle of superposition. Okay. Okay. Now let me give you some numericals. Then only you can understand how to determine the direction of force. Okay. So this is very important. Again, I have told. Let me tell you that to find the direction of force, only two things you have to remember. That is, the like charges repel, unlike charges attract. Repel means it's go away. Attract means what? Come closer. Only this you have to remember. Rest is very simple. Only just calculations. Okay. So one question let me give you. Simple question. Suppose calculate the force between the Coulomb force between two alpha particles placed at a distance of 1 meter in vacuum. So calculate the Coulomb force between two alpha particles placed at a distance of 1 meter in vacuum. So here only two charges are there, so you need to apply the superposition principle. If there are more than two charges, then only apply superposition principle. Okay. So now what is alpha particles? Alpha particle means what? That is helium nucleus. Okay, helium nucleus is the alpha particles. The helium nucleus is the alpha particles. Now two alpha particles are there. So since both are alpha particles, they have same charge. So here Q1 is equal to Q2. Okay, is equal to what? The charge, the charge number of helium is what? 2, and the basic charge is E. Okay, because helium nucleus, it is 2 protons. Okay, it is 2 protons, so it is 2E. Nucleus means there is no electrons. Okay, so it is 2 into 1.6 10 to the power minus 19 coulomb. So this is 3.2 10 to the power minus 19 coulomb. Now here the distance R is also given 1 meter. So you can easily calculate force. So you just apply the formula 1 by 4 pi epsilon Q1 Q2 by R square. So here this I have already given you this value, 9 10 to the power 9. So here 3.2 10 to the power minus 19 into 3.2 10 to the power minus 19. R is what? 1. Okay, just rest you just calculate. So here 9 into 3.2 into 3.2 into 10 to the power, here it is 9, so 10, it is minus 29. So rest you can calculate, so it comes in what? Force, it is Newton. Rest you calculate. So here you see, since we have only two charges, so you need to apply what? Superposition principle. Only just you have to repel here, you put, they what? This force is what? Since both are positive, so they repel. You can just write, they repel each other. But if there are more than two charges, then you have to apply superposition principle. So for that, let me give you an example. So if there is more than two charges, then how can you calculate Coulomb force? So for that, you have to apply the principle of superposition. That means you have to find the direction. So you take another question. Find Coulomb force on each of the charges as shown in figure. So you consider a equilateral triangle. We assume this equilateral triangle, okay? So its distance same, 1 meter, 1 meter, 1 meter. And suppose here there is a charge of 1 Coulomb charge at this suppose triangle A, B and C. Here so 1 Coulomb, here it is 1 Coulomb, and say it is minus 1 Coulomb. So in the vertex A, 1 Coulomb charge, in vertex B, 1 Coulomb charge, vertex C it is minus 1 Coulomb charge. Now you have to find the force on what? Each of the charges. So here first let us consider force on the charge at A. Okay. So I will show you the calculation for A, and you do yourself by force on C and B. Okay. Now when you consider this charge, we have to find the force on this charge due to other two charges. So I have already told you, you have to only see what? Nature of charge. Okay. Like charge repel, unlike charge attract. Now this charge, you see, we have to find out the force on this. Here 1 Coulomb charge. Now this is negative. So this charge what? Attract this charge. Attract means what? It come towards. Okay, attract. So this is the force F AC. AC means what? Force on charge at A due to charge at C. Now you find the direction due to this. Now this is 1 Coulomb. This is also 1 Coulomb. So both are positive here. Now this charge what? It repel this. Okay, it repel this. Because this is positive, this is positive. Repel. Repel means what? It's away. Because it will go away. Repel. So F A B means force on charge A due to charge B. So this is the force FSC. This is force FB. Okay, so I repeat. You just see careful direction. So this we have to find out the total force on A. That means force on A due to B and C. Now this charge is negative, so it will attract this charge. So it is direction this one. Attract means it's come towards it. And this is positive charge. This is also positive charge, so it repel it. Repel means it move away. So this is FAB. Clear? Now you have to find the resultant. So resultant means what? You apply vector law. So this is the resultant force. So this is suppose FA. You have to find out FA. Now what is this angle? This is 60 degree because I have considered equilateral triangle. So this is what? 120. Rest you know, you can easily find out. So first you find the magnitude. The magnitude of FAB. FAB means what? Force on between these two. So it is 1 by 4 pi epsilon Q1 Q2 by R square. So here it is 9, 10 to the power 9, Q1 is 1, Q2 also 1, distance also 1. Okay. So it is FAB, it is simply 9 into 10 to the power 9 Newton. Then F, you find out AC, 1 by 4 pi epsilon Q1 Q2 by R square. Here also it is same, 9 10 to the power 9, 1 into 1 by 1 square. Now here you need to put minus sign. This is very important. Here you see this C, it is minus 1 coulomb, but you need to put here because already you find the direction. It is negative, that's it is attractive. Okay, so already you find direction. So you don't put negative sign here. We are only taking the magnitude. So here you have to put positive sign. Okay, because since it is negative, that's why it is what? Attractive in nature. So don't put negative sign here. It is 9 10 to the power 9 Newton. So it is, now we find the total force. You apply vector law. I think you remember, I have already discussed in class 11. So it is what? You tell me, FAB square plus FAC square plus 2FAB FAC into what? Into cos theta. What is theta here? Theta is 120. 120. Rest you can calculate. Okay. So it is what? 9 10 to the power 9 whole square plus 9 10 to the power 9 whole square plus 2 into 9 10 to the power 9 into 9 10 to the power 9. What is the value of cos 120? It is minus 1 by 2. Okay. So this 2 to cancel out. This 2 to cancel out. So here it is 9 10 to the power 9 whole square plus 9 10 to the power 9 whole square minus 9 10 to the power 9 whole square, because it is minus. So this cancel out. So ultimately what we get? 9 10 to the power 9 Newton. So this way you can find out the force between what? Multiple charges. Okay. The only thing is that you have to find the direction. And for direction, what you have to remember? If like charges means both positive and both negative, it is repulsive. Move away. Okay. And if it is one positive and the negative, means unlike charges, attractive. For attractive, it's what? It's attract, so come closer, and repel means move away. Only this thing you have to find out. Others is very simple. Okay. Simple calculations, only the vector calculations. Okay. So now you can do yourself to find the resultant force on C and resultant force on B. Okay. And if you find any difficulties, you can ask me. Clear? Okay. Thank you.